For your 3.8 notes here about logarithmic differentiation. We kind of started this a little bit yesterday but didn't get very far. So when you see a function that has a variable in the base and a variable in the exponent like this one does, that's when you will need to use this process. So step one, you need to take the log of both sides of the equation. Okay, we're going to choose to use natural log usually. Alright, so you take the natural log of both sides. That allows you to do step 2, which is to take the exponent and move it down in front and make it a coefficient. That is one of the laws of logarithms that allows us to do that. Step 3, once you have the variable no longer being an exponent but being a coefficient instead, that means we can use the product rule now to find the derivative of this on the right hand side. So breaking down the 4 parts of the product rule, you would have x and 1 for the f and f prime, and then the g's natural log of x plus 1, and its derivative is 1 over x plus 1. So you would take those 4 components, put them into the product rule, and you would get this right here. Alright, on the left hand side you'll notice that this is switched from originally it was written explicitly with the y by itself, but once we took the log of both sides, it's not written explicitly anymore. It is now written implicitly. So when you take the derivative of this natural log of y, it'll be 1 over y multiplied by dy over dx, since you're treating y as a function of x. Alright, next step is to try to solve for dy over dx. Okay, so right here we're trying to get dy over dx by itself, so we multiply both sides by y, and that gives us a y on both of these two terms. Okay. Alright, the last step, it says you're supposed to write if possible, write your answer in terms of x. So the y's that are over here we are going to replace with what y equaled. So you look back at the original equation up here, and y was equal to x plus 1 to the power of x. So the y's that we had in this equation here, both of them, we're going to replace them with x plus 1 to the power of x, so that our final answer is all written in one variable instead of with 2. Alright, so that would be it for that one. Let's look at a second example. X to the sine of y equals y to the cosine of x. This one is both written implicitly, and we have variables both in the base and in the exponent. So we're going to use the logarithmic differentiation, but we're also going to have to do some implicit differentiation along the way. Alright, so first step, again, take the log of both sides of your equation. That allows you then to move the sine of y down on the left side and the cosine of x down in front on the right side. Alright, so looking at that equation, then each one of the sides now would require the product rule. So on the left hand side here are the 4 parts for the product rule: sine of y, and then cosine of y times y prime. Y prime, remember, is just another way of writing dy over dx. And then the natural log's derivative is 1 over x. And on the right hand side we've got cosine of x, derivative of that is negative sine x, and then natural log of y's derivative is 1 over y times dy over dx, or in other words, y prime. Okay, so we take these 4, write out the product rule on the left side, take these 4, write out the product rule on the right side. Did a little bit of simplifying in there in terms of combining signs and fractions and so forth, but that would be what you get after using the product rule twice. Okay, so just like we did with implicit differentiation a couple sections back, we would try to get the 2 terms that have the y primes in them. Okay, so that'd be this term right here, this term over here. We want to put them on the same side of the equation, and then we want the terms that do not have y primes, which would be this one and this one, on the other side of the equation. So I'm going to swap those two, subtract this one over to the left and subtract this one over to the right, and that gives us this equation right down here. Alright, so once you've got the y prime terms all on one side, you can factor out the y prime. And so once you factor out the y prime, you're left with natural log of x times cosine y minus cosine of x over y. And then you're trying to get the y prime by itself, so you would take this entire factor right here and you would divide it over to the other side of the equation. So your final answer would end up being, I don't have it written on here, but it would be y prime equals this negative natural log y sine x minus sine y over x, all divided by this quantity right here.